lumen is clean, but due to side lobe artifacts, we can see some internal echoes. These echoes are wrong placed in the bladder. Okay, now our next topic. It is SPI most favorite topic, and you will get a lot of MCQs from this topic: spatial resolution and all its 3 types. So every single line of this topic is important. First of all, what is spatial resolution? Dr. Awadia, can you give me answer?
Yes, ability of ultrasound system to differentiate or to distinguish two separate reflectors.
Yes.
That are close to each other.
Yes. And there are 3 types: axial, lateral.
There are 3 types.
Yes.
Lateral, axial, and elevator.
Yes, axial, lateral, and slice thickness are elevational resolution. And what is the difference between them?
Axial resolution is the structure located along the beam axis or parallel to each others. Lateral resolution perpendicular is mainly affected by transducer frequency. Lateral resolution is perpendicular to the beam axis or structure lies side to side to each others, while elevation one point in front of or behind another object.
Okay, very good. Axial resolution.
Lateral resolution affected by beam width.
Yes. Axial resolution along the beam axis, front to back. Lateral resolution perpendicular to the beam axis. Objects are side to side placed. Slice thickness, also known as elevational resolution, and this is along the vertical plane and into out of the screen. Now, first of all, axial resolution. So, axial resolution is the system's ability to differentiate between 2 closely spaced structures along the beam axis, as we can see here. So, as our beam is coming like this, so axial resolution, its ability to differentiate 2 objects which are placed along the depth, along the axis of the beam. Lateral, which are placed perpendicular 90-degree angle to the beam. Elevational resolution, so it is along the height of the beam. Ability to separate structures parallel to the ultrasound beam, this is known as axial resolution. As you can see here, there are 2 structures, and ability to differentiate these 2 structures as separate, this is known as axial resolution. Now, what are the other names of the axial resolution? These are very much important. Its names are longitudinal, range, depth, and it is determined by spatial pulse length. SPL, spatial pulse length. Okay, so here we can see spatial pulse length. Dr. Awadia, what is the spatial pulse length?
Spatial pulse length is the number of pulses produced by second.
Number of pulses transmitted per second is pulse repetition frequency. Spatial pulse length is associated with the wavelength, like something similar to the wavelength. Desveen, what do you think?
SPI is equals to the formula wavelength times number of cycle.
Numbers are distance.
The distance.
Yes. So it is
The
the
distance over which
distance.
the
Yes.
pulse were traveled.
Yes. So individual cycle distance was wavelength. Here we can see a pulse. Pulse means there are more number of cycles, like more than one. Their combination of the cycles. So now in this pulse, the total distance is called the SPL. So we can say length of a pulse from the start of one pulse to the end of the same pulse. So this is our whole pulse. So its whole length from its start to its end. This is known as spatial pulse length. And spatial pulse length is related to the wavelength. So its formula is SPL is equal to number of cycles in a pulse multiply wavelength. And its unit is millimeter. So this is our SPL, spatial pulse length. It depends on wavelength and number of cycles per pulse. And the key point for the exam is shorter SPL, better axial resolution. To improve axial resolution, reduce the SPL or reduce the wavelength or improve the frequency. So, to reduce the SPL, to improve the resolution, reduce the SPL. To reduce the SPL, either decrease the wavelength or decrease the number of cycles in the pulse. And we know decrease the wavelength. So wavelength is inversely related to the frequency. Decrease the wavelength means increase the frequency. So all of these things improve the axial resolution. And we should also know about its formula. Axial resolution is equal to SPL divided by 2. Axial resolution is equal to SPL divided by 2, where SPL is number of cycles multiply wavelength. Unit is millimeter. Smaller the value means better resolution. The smaller the value of the resolution, it means it's good. So Tesween, what do you think? Which is a better axial resolution? 0.1 mm or 1 mm?
0.1.
Yes, because smaller the value, good resolution. So, for good resolution, SPL is increased or decreased? Tesween?
SPL should be reduced.
Yes, because reduced SPL means axial resolution value will be small. Small value means good resolution. Now typical values according to the frequency. Frequency 3.5 MHz, resolution 0.6 mm. Frequency 5 MHz, resolution 0.4 mm. Frequency 6.5 MHz, resolution 0.3 mm. Dr. Awadia, now which frequency has the highest resolution?
6.5 megahertz.
Yes, higher the frequency, better the resolution. And one more thing is, axial resolution is constant along the beam. What about lateral resolution? Is it constant or is it changing along the beam?
Changing along the beam.
Yes.
According to the beam width.
Because lateral resolution depends on the width of the beam. Narrow the beam, better the lateral resolution. So lateral resolution not same in whole beam, but axial resolution is constant along the whole beam. It does not depend on the width. It depends on frequency, Better frequency, better resolution. Depends on SPL. Shorter SPL, better axial resolution. And to reduce the SPL, we can reduce the number of cycles, we can reduce the wavelength as well, or we can increase the frequency. To get the most accurate measurements, align the calipers along the beam axis because this utilizes axial resolution. So you should align your calipers along the beam axis. Axial resolution, its synonyms, to remember them, mnemonic is LARD. L for longitudinal, A for axial, R for range, and D for depth. Okay, Tasween, can you please now repeat their names?
Alright, so we have LARD. Okay, L is for longitudinal, A is for axial, R for range, is D for depth.
Okay, good. Longitudinal, axial, range, depth. Okay, next one is the lateral resolution. So lateral resolution refers to the ability to differentiate two structures that lie side by side, are perpendicular to our beam axis. As you can see here, this is our transducer, so beam is coming like this, and these two objects, they lie side by side, so they are perpendicular to our beam axis. And in axial resolution, they are like just parallel to our beam axis. So we say axial resolution differentiate the objects which are placed along the beam axis or along the depth of the beam. And lateral resolution, so lateral resolution in objects are placed perpendicular to our ultrasound beam. So Tasween, what do you understand by this diagram?
Alright, so from this diagram, it is seen if at the point of the Fresnel, okay, the near field, the beam will be assumed to be one structure, okay, but and same thing goes in the far field as well. But yet the focal zone, I'll say focal zone, it is the best because it will be seen separated side by side as two whole structures.
What do you think? What is the reason why in the near field and far field we can't differentiate them as two structures?
Because the beam width is large in near field and far field, while in focal zone is narrow.
Excellent. Because in the near field and far field we can see beam is too wide. Beam is too wide. So as think of two candles placed side by side, and a whole beam covers them, includes them. So both reflectors are hit at once. We see one candle, not two. So because these two objects, they are located within the beam width. So beam, because these are under the beam width, so they are taken as one structure. Because here beam is now thin, so it can differentiate that there are two different structures because these both reflectors are not hit at once. This beam width covers only this one at one time. So it would be differentiated as two structures. So lateral resolution depends on the beam width, best in the focal zone where beam is narrowest and worse in near and far zones. And how to improve the lateral resolution? We use focusing, because focusing makes the beam width narrow. And what are the synonyms? Azimuthal, angular, and transverse. Lateral, azimuthal, transverse, angular, and determined by beam width at a particular depth. So lateral resolution depends on the beam width. Best lateral resolution is found in the focal zone. Very important MCQs. Best lateral resolution is found in the focal zone, where the beam is narrowest. And lateral resolution is, it depends on the beam width. And lateral resolution is not constant and change with depth. Poor in near and far zones and best in the focal point. Improves by the focusing. Unfocused transducer, best resolution at the transition point between the far field and the near field, because at this point beam width is almost 1/2 of the transducer diameter. For the clearest separation of structures across the beam, always place the region of interest in the focal zone. So here's a mnemonic, LATA for the lateral. Lateral, late. So LATA. So it stands for lateral, azimuthal, transverse and angular. Now the comparison between the axial versus lateral. Dr. Awadia, can you please now summarize this?
Yes. Axial versus lateral resolution. For axial resolution, the structure lie along the beam axis or the depth of the beam. It determined by spatial pulse lengths. If we decrease spatial pulse lengths, wavelengths, or increase transducer frequency, the axial resolution improves. It's not, it is a constant with the depth, unit millimeter. While for lateral resolution, its ability to differentiate structure lie across the beam axis or beam width perpendicular to the beam. It determined by beam width. It is the constant, not varies with the depth. The unit is millimeter. If we decrease the beam width, we improve lateral resolution. It adjusts with focusing. If we do focus, the lateral resolution increases.
Excellent.
The axial resolution generally is better than lateral resolution. Always constant, while for lateral resolution it improves at the focal zone. If the structure lie in the area of focal zone. For axial resolution, it improves by damping, because damping reduces excessive vibration and decreases spatial pulse length, and it improves by higher frequency.
Yes.
While for lateral resolution, it improves by beam focusing.
Yes. So here comes another very important point, that is damping. So again, favorite MCQs in exam, damping. Axial resolution is improved by damping, because damping makes the pulse short. Damping decrease the SPL. Yes, damping decrease the SPL. So damping makes the axial resolution good. This is favorite MCQs. Okay, so now we will revise this through MCQs. Tasween, what is the beam axis in ultrasound imaging?
It's B, center line of the ultrasound beam.
Okay, very good. Dr. Awadia, which of the following statement about side lobes is true?
They can produce artifacts if reflected back.
Okay, good. What type of artifact can occur when echoes from side lobes are mistakenly placed along the beam axis?
C, side artifact.
Okay, very good. Dr. Awadia, which describes best axial resolution?
Ability to separate reflector along the beam axis.
Okay. This means which factor primarily determines axial resolution?
SPL.
Okay, good.
It's SPL divided by 2.
Yes. Dr. Awadia, a transducer has 4 cycles per pulse and a wavelength of 0.3 mm. Okay. What is its axial resolution?
Axial resolution is 0.6 mm.
What is the formula for the axial resolution?
Axial resolution SPL over 2.
And what is SPL formula?
Equal 2 wavelengths.
SPL formula is
Wavelengths divided 2.
sometimes they
The
ask
number of
this
cycle
formula in the exam as well.
wavelengths. Yes, number of cycle multiply wavelengths. Yes.
Yes, sometimes.
This means that SPL is 4 multiply 0.3 is 1.2. And axial resolution is SPL over 2 is 0.6 millimeter. Yes.
Yes. 3.3
yes.
multiply 4 is 1.2, divided by 2 is 0.6 millimeter. And this formula is very important for the exam. This formula again is very important for the exam. All of the things we discussed about the resolution, each and every point is very much important for the exam. Which transducer has the best axial resolution, Tesween?
Uh, 6.5.
Yes. Good. The higher the frequency, good resolution. Let Awadia, where is lateral resolution the best?
At the focal point.
Yes. Yes, very important. This means what happens to lateral resolution outside the focal zone?
It worsens.
Yes, it worsens in the near and far zone and best in the focal point. Let Awadia, axial resolution is usually better than lateral resolution because
It does not change with the depth.
yes. This means which of the following term is not a synonym for axial?
C.
Which one?
C. Azimuthal.
Okay, good. So axial resolution is also known as longitudinal depth,
Axial, range and depth.
range, yes. And azimuthal is equivalent to lateral. Lateral, lata. Lateral, azimuthal, transverse, and A for A stands
Angular.
for what?
Angular.
Angle.
Angular. Okay, good. Now to Awadia, which technique improves lateral resolution?
Focusing the beam.
Okay, good. Tesween, what is the unit of both axial and lateral resolution?
C. Millimeters.
Yes, millimeter. Good. Tata Awadia, if two reflectors are 0.4 millimeter apart along the beam axis and axial resolution is 0.6 millimeter, how will they appear?
The two separate echo.
Tesween, what is your opinion?
A. As a blurred one structure.
As one blurred structure, yes, because reflectors are small, their distance is small, only 0.5 millimeter apart, but the axial resolution is, its value is more, 0.6 millimeter. It means it could not separate them. The smaller the resolution, the better the results, but now it's more than the distance between the objects, so they will appear as one blurred structure. If reflectors are closer than the axial resolution, system cannot differentiate them separately. Okay, Tesween, which of the following does not affect lateral resolution?
pulse duration?
Yes, pulse duration. Because we know when transducer diameter is increased, what it does?
Beam width is
More focus beam, narrow beam width. So it also improves lateral resolution. But pulse duration, no effect. So pulse duration affects axial resolution, not lateral. Lateral resolution is governed by beam width, which can be improved with focusing, transducer size. Hi everyone, I am Hina Wajid and I have passed my ARDMS exam with 94% marks in SPI and 94% marks in OBGYN. Now here on YouTube, I share SPI related MCQs and tips to help others pass ARDMS exam too. If you want full SPI session and all topics explanation according to ARDMS content outline and their syllabus, then you can find the link in the comments to check some of the free PDFs, some of the free videos, and you will also find details how to contact us to join our complete session.